All right. Good morning, folks. Hopefully, you had a chance to look at the homework from last night. So, I want to do a couple of homework problems today, just to kind of give you a chance to see how the homework is done. Make sure then that if you have any questions about the homework, come by and see me. So, let me go ahead and set the timer here. Come by and see me and get some extra help with it. But like I said, today in the video, I want to work through a couple of homework problems with you, one from the previous set and one from the set that is just signed, to give you a chance to see how the problems are done. Make sure you write them down, and then make sure then that you compare it with the work that you've done for your own homework assignment. Okay, so make sure you get the homework done, folks, and then come by and get that extra help if you need it. Okay. All right. What I would like to do today then is I want to try to finish up with this discussion of limiting reagents. We'll do a couple. We'll do this problem here, and then I want to go ahead and I want to start talking about how we can use that information. That is, once we find out what the limiting reagent is, to determine then how much product will form. That's the goal then, is that if we know what the limiting reagent, remember the limiting reagent is the reactant that runs out first, and it limits how much product will form. That's why we want to identify the limiting reagent. So once we have that information, what we need to be able to do with it is be able to predict how much product will form. And that's what I want to start out with today, which again will involve, and you're going to notice here when we do those problems, involve another stoichiometric calculation. Okay? The stoichiometry then, and that is, remember, stoichiometry is the comparison of quantities in a chemical reaction. Stoichiometry is going to be important. So learn how to do those calculations because we'll be applying that the method that we learned, and basically it's just a conversion, one long conversion. Apply that method to determining limiting reagents, which we've done here, and what we did yesterday, and what we'll do today, which is to predict how much product will form as well. Okay. All right. So we left off with this problem yesterday. Okay, and I asked, this is number 12 in your problem set. And so when we are going to identify a limiting reagent, and I told you then that there's a couple ways that you can go about doing this. You don't have to do both calculations, okay? But you choose one. However, what I told you, what I told you yesterday is that I want to go ahead and work out both for you. Okay? And so what I did was, what we did yesterday then is I took the amount of so let me go ahead and do this. I took the amount so we were given these amounts. So this is the chemical reaction right here, okay? The chemical reaction here, we were given these amounts here of each of the reactants, and we were asked to define what the limiting reagent is. So in the very first conversion here, in the very first stoichiometric conversion, I just went ahead and I arbitrarily chose 5 grams of magnesium. So that was the given amount. So that's the given amount of magnesium. What we did in this first calculation is that we calculated for the amount of hydrochloric acid that would be needed, the amount of HCl that would be needed to use up all of this 5 grams of magnesium that we were given. We calculated then that we needed 15 grams of HCl to completely use up 5 grams of magnesium. And then we compared this calculated value to the given amount of HCl. And we saw then that the calculated amount that's needed is a whole lot bigger than the amount that was given. What does that mean then? That means then that HCl we don't have enough. We don't have enough HCl to use up these 5 grams of magnesium. Therefore, from this very first calculation, we can conclude that HCl is the limiting reagent. It will run out first. So the 6 grams here of HCl will run out before the 5 grams of HCl magnesium will run out. Therefore, it is the limiting reagent. Okay? So this is the limiting reagent. We could have stopped right here because that's what the question was asking. Okay? So if that was the limiting reagent, we can say then that the excess reagent then is going to be magnesium. Okay, so the excess magnesium, and we were able to obtain that answer, these two answers here, that magnesium is excess and that HCl is limiting. Okay, we can obtain that simply by doing this first calculation here. Okay, but let's say then, and this is what I wanted you to do yesterday. Let's say then that you didn't choose the 5 grams of magnesium, but you had instead chosen the 6 grams of HCl to do instead. Okay, well, what you would do then is you would carry out the calculation. Let's go ahead and do that right now. Okay, so we'd start out with 1 mole, use the molar mass of HCl, 1 mole of HCl over 36 grams of HCl. Use the molar mass of, mole ratio between magnesium and HCl, and that would be a 1 to 2. So just flip that around, be 1 mole of Mg over 2 moles of HCl. And then finally use the molar mass of magnesium. We'd multiply it by that. So 24 grams of magnesium over 1 mole of magnesium. Okay. All right. And so if you plug that in, you'll get your answer then as being 2 grams. So what would be here would be 2 grams of magnesium. Okay. So this then represents, okay, the 2 grams there represents the calculated amount of magnesium that we need. So this is the amount needed. So this is the amount of magnesium needed if we wanted to use up all of the 6 grams of HCl there. So let's go ahead and do the comparison. So the calculated amount of magnesium, okay, that's the amount that we need, is 2 grams. So we only need 2 grams of magnesium, okay, to use up the 6 grams of HCl here. But how much was given? So we were given in the problem that we have actually 5 grams of magnesium, which means that we have a whole lot more of the given. We have a lot more of the magnesium than what we need, which leads us to conclude then from this calculation that the magnesium is excess, which we have already concluded here. And if magnesium is excess, the HCl is the limiting reagent. So it doesn't matter which one of these calculations you choose to do, folks. It doesn't matter which one you choose to do. You can still obtain the same answer. You can still obtain the same information here. It's just you get this first, doing the second calculation. You obtain then that magnesium is the excess. And then from that, since there are only 2 reactants, you can conclude then that HCl is the limiting reagent. So regardless of which one of these calculations you choose to do, you're going to end up with the same limiting reagent. You're going to end up with the same excess reagent. Okay. All right. Very good, folks. Let's go ahead then. Let's continue on then. And what I'd like to do is I want to apply this, calculation, apply what we've got here with the limiting reagent to find out how much product is going to form. And I started this yesterday, and then, I wanted to work out one more limiting reagent problem with you. But to find out how much product we're going to get, first of all, this is the stoichiometric calculation. So what we have to do, get the balanced equation first. Always get the balanced equation first. That will always be your starting point for these calculations. Okay? And then what you want to do, if you want to find the amount of product that's going to form, you have to decide which one of the reactants is the limiting reagent first, because then that will determine then how much product you're going to form. So you got to do the limiting reagent calculation first. So you got to do that, okay? And then from that, then you want to find out the mole ratio between limiting reagent and whichever product you want to solve for. Okay? Once you have that, you can go ahead then, and we can use that to find the amount of product that will form, and then the moles of product that will form. And for that, then you will convert it to either mass or volume, depending on what we need. Okay. All right. That's a whole lot of steps. Okay. So let me just make sure you understand that we have 5 steps here. 5 steps here. You don't want to memorize this. You want to make sure you just work it out. Okay. But essentially, then we're going to be doing 2 separate stoichiometric calculations. Okay. We're going to be doing 2 separate calculations. One involving the limiting reagent, that's going to be step 2. And then finally, okay, so that's going to be calculation number 1. And steps 3 through 5 involves calculation number 2. 2 stoichiometric calculations. And what you want to make sure you keep that in mind. You're going to do 2 of those, okay? And so with that said then, if you keep that in mind, it's going to be pretty straightforward for us. Okay, so keep that in mind. Let's go ahead then and let's take a look at a sample problem. Okay. All right, so let's take a look at this problem here. We have the reaction. We've done this before, okay? And so let's go ahead then and let's work this one out together. Okay, let's work this one out together, okay? And remember, I told you that we're going to be doing 2 separate calculations here, okay? All right, so let's go ahead and let's write down, and let's go ahead and write down what we were given. Okay, so the equation is balanced, okay? It's balanced already, okay? We were told then that we have 80 grams of copper, so let's go ahead and write that down. So this is given. The given amounts, okay? So what's given here is 80 grams of copper and 25 grams of sulfur, okay? All right, so we want to find then the amount of product. The question's asking here then the grams of CO2. So we're trying to find C2S, okay? We're trying to find out how much product will form. But which one of these two will determine how much product will form. Will it be 80 grams of copper or 25 grams of sulfur? Okay, so what we have to do first is we have to find the limiting reagent. Which one of these two is the limiting reagent? So this is going to be calculation number one. Okay, so with that said, I'm not going to do both of the limiting reagent calculations. I'm just going to choose one of them. And I'm going to arbitrarily choose copper here. So we're going to start then with 80 grams of copper. Okay, and remember, for this first reaction, for this first calculation, then we want to find out then how many grams of sulfur is needed. Okay, so with that said, then this is our first calculation. This is our limiting reagent calculation. And so with that said, then we need 3 conversion factors. Let's go ahead and plug that in. Okay. All right, so the first conversion factor then is going to be then the molar mass of copper, 1 mole of copper, and copper is 64 grams. So let's go ahead and 64 grams. That's the molar mass of copper. Mole ratio between copper and sulfur is going to be a 1 to 2. So it's going to be 1 mole of sulfur, 2 moles of copper, and then finally then the molar mass of sulfur here. And I'm sorry, let's go ahead and do this. 32 grams of sulfur, 1 mole of sulfur. Okay, so we have that then, and so we'll end up here with a mass of let me go ahead and get this for you, 20 grams of sulfur. Okay, so let me go ahead and let me just check that really quickly. I just want to make sure I got that right. Okay, so let's go ahead then. 80 divided by 64 divided by 2 times 32. Yeah, 20. Okay, so let's go ahead then. So this is the calculated amount. So this is the amount that we need. Okay, and so let's compare that to the amount of sulfur that we have. So we have then the calculated amount is 20 grams of sulfur. The given amount is 25 grams of sulfur. The given amount is greater than the calculated amount, which means then that the sulfur is excess. So the sulfur here is your excess. From our calculation, we have more sulfur than we need, which means then that the copper is the limiting reagent. Okay, so make sure if you're not quite sure how we got this, work on this some more, and then come by and see me get that extra help. But we needed to do this calculation because now, if we know that copper is our limiting reagent, we can set up the second of our calculations. Okay, so let's go ahead and set up the second one, which will now allow us to determine how much copper 1 sulfide will form. Okay, so the second conversion then, again, we'll start with 80 grams of copper. Why? Because it's our limiting reagent. This time, though, we're trying to find then the amount of copper of product that will form. Okay, so look at the difference between the two calculations here. But both calculations will also involve stoichiometry. Okay, but this time we're just going to plug in different conversion factors here. Okay, but the first one's going to be the same because this is copper here. Okay, so it's going to be 1 mole of copper over 64 grams. That's the molar mass of copper. But the second one here is going to be the mole ratio between copper 1 sulfide, the product here, and copper. Okay, so that'll be 1 mole of Cu2S and 2 moles of copper. Notice this conversion factor here, this mole ratio is different from this mole ratio here. Okay, so this mole ratio here is between copper and copper 1 sulfide. Okay, all right, so with that said, then the last conversion factor is going to be the molar mass of copper 1 sulfide, 2 coppers, 1 sulfur. That's going to be 159 grams of Cu2S for every 1 mole Cu2S. Okay, all right, so with that said, then you plug it in, you're going to get your final answer then is 99.4 grams of copper 1 sulfide, and that, folks, is your answer. Okay, all right, so you need to be able to do both calculations. Okay, the first calculation, let's go ahead and write this down. This is the limiting reagent calculation. Okay, so you need to do that to determine which one of these two reactants is the limiting reagent. The second one is the product calculation. And I call it the product calculation because here you're trying to find the amount of product that forms. So you have to do both calculations in order to answer this question. The question then is asking you just how many grams of product will form. Okay, so you have to determine the limiting reagent first. Okay? And this is especially true. This is especially true when you're given the amounts of both reactants. Now, we can skip the very first calculation. We can skip that limiting reagent calculation if the problem tells us which one is the limiting reagent, or they tell us if one of those two is the excess reagent. And we saw that early on. We saw that early on when we did these problems on Monday. Okay, so if the problem tells us what the excess reagent is, if the problem tells us what the limiting reagent is, we can go straight to the second calculation here. We don't have to do the first one. But if the problem does not, folks, you have to make sure you do this calculation, especially if you're given the amount of both of the reactants here. Whenever you see a problem that gives you the amount of both reactants, whether it's in moles, whether it's in mass, like we have here, or whether it's in volume, you got to make sure you do this first calculation here, okay? All right, let's go ahead and let's do a problem then. Let's do a sample problem. Let me ask you to number 20 in your problem set. Take about 5 minutes, okay? And we'll finish 5 minutes here, work out this problem here, and then we'll work it out together. Okay, take about 5 minutes. Okay, number 20 in your problem set, set up the problem. We're doing here, I'm asking for both calculations. Okay, let's get that done, and then we'll work on it together. Okay, so go ahead, get it done. All right, let's go ahead then. Let's take a look at this problem here, folks. Okay, let's take a look at this problem here. Whoops, let me go ahead. And okay, let's work this one out together. Okay. All right, let's go ahead then and let's write out what we have. Okay, let's write out the balance equation again. They give us the balance equation as C2H4 plus O2 to produce then, CO2 plus H2O. Okay, in a 1 to 2, this is carbon monoxide, sorry, CO, the incomplete combustion of ethane. Okay. 1, 2, 2, 2. Okay, that would be the balance equation first. Let's go ahead and write down the amounts that we are given. Let's go ahead and write out the given amounts. Okay. All right, so we are given here then that we have 2.70. And mind you, make sure you look at the units here. There's 2.70 moles of ethene, C2H4, and 6.30 moles of oxygen. This is going to simplify our calculations a little bit because we already have moles here. Okay, so the quantities that we are given in moles. But remember, like I told you from the previous slide, if you're given the amount, regardless of what it is, okay, if you're given the amount, you have to do the limiting reagent calculation. So let's go ahead and let's do that first. Okay, so the limiting reagent calculation then, you can choose either one of these amounts. I'm just going to go ahead and choose this one here. So we're going to start out then with 2.70 moles of C2H4. And in this first calculation, we need to find out how many moles of O2 are needed. Now again, this is moles to moles, folks, so we only need one conversion factor, and that's the mole ratio, which is a 2-to-1 mole ratio. We don't need the molar mass here, so don't use that because the unit here is already in moles, and we're solving for moles. So we don't need the molar mass, we don't need the molar volume, we don't need any of those in this problem. We just need the mole ratio, okay? All right, so it's gonna be 2-to-1, 2 moles of O2 over 1 mole of C2H4, okay? And you plug that in then, you end up with 5.4 moles of oxygen. So this is our calculated amount, okay? So that is the amount of oxygen that is needed to use up all of this starting amount of C2H4. So let's go ahead then and let's compare the calculated amount versus the given amount. Okay, so the calculated amount then of oxygen is 5.4 moles, okay, and of O2, and the given amount is 6.30 moles of O2. So the given amount, what we have is a lot more than what we need. So what does that tell us about O2? It tells us that O2 then is the excess. So we know then that O2 is the excess. Sorry. Oops, sorry. O2 Okay, so we know then that oxygen is the excess reagent, which means that, so from this calculation, O2 is the excess, which means then our limiting reagent is C2H4. Okay, so we've come up with that. So from our first calculation, we've determined then that the limiting reagent, we've answered the first question, is C2H4. So we've answered the first question. Okay, now the second question asks us to find out how much product will form. Okay, calculate how much water will form. So they want us to find out how much water here will form. So the question is asking us about water here. Okay, so our second calculation then, our second stoichiometric calculation will be then the conversion between 2.7 moles, 2.70 moles of C2H4. And understand why we're using this amount again. We're using it because it is the limiting reagent. But this time, though, instead of finding the moles of oxygen, we're going to find the moles of water that is going to be produced. Okay, and again, for this particular reaction calculation, we don't need any of the other conversion factors because the units here are already in moles. So this is a moles to moles conversion. So we just need the mole ratio here, which is going to be a 2 to 1 mole ratio. Okay, so it's going to be 2 moles of water and 1 mole of C2H4. Okay, and so if you plug that in, you'll get your final answer as 5.40 moles of water, and that's how much water we expect to form. Okay, all right, very good, folks. So tomorrow, then, like I said, we're out of time here. So tomorrow, what I want to do is I want to work out a few more of these problems with you. Okay, a couple more of these problems with you from your homework. So please make sure you try to get the homework done for tonight. Okay, and then we'll pick up with this discussion tomorrow. Okay, all right, very good. So folks, if you have any questions on how to do this, come by and see me so you get help with this, and then I will see you folks tomorrow in lecture. Okay, have a good day, folks.